Welcome. Today I'm going to take you through the steps to control and download data from your Rigol DS1054Z oscilloscope using Python inside of a Jupyter notebook. We're going to begin by using the DS1054Z library from Philip Klaus. If you don't have this, you may have to have pip and put it in your environment. We're also going to need a couple of the matplot lib functions as well. This one's fairly common. The other one is a little less used, but it allows us to adjust the ticks in our plots so that that matches what the scope displays. That's a little easier for us to check. And we're going to use NumPy as well. All right. Since we're going to be dealing with bitmaps, we're also going to use the IPython display library. All right, and that looks good. Now we get into the fun stuff. Let's verify the connection to the scope. IP address for the scope, and we're just going to print the scope identification number. That looks great. Move on to the next step. Let's put the scope in run mode. Be sure that it's collecting data. And if you're watching the inset, that was already a green light indicating it was in run mode. If we wanted to, we could put the scope in stop mode. And if you're watching the inset, that light just turned from green to red. So we'll go back up here, leave it in run mode. You can see that light change. All right, let's grab a bitmap off of that scope. And we'll display it here in the notebook. It always takes a second or two for this to come up. Ah, there it is. Looks fantastic. So we can see the scaling on the vertical axis, scaling on the horizontal axis, 20 milliseconds per division. We can see we have a trigger on the rising slope set at 780 millivolts. Everything on here looks good. So one of the things you can do remotely if you're not happy with how the data is displayed in the scope is we can change the scale factor. So to do that, we can use the command built into the library. We're going to change channel 1 and we're going to change it to 0.5 volt per division. And if you're watching the inset, you should see that change on the scope there. And we'll just grab a new bitmap. I'm going to be lazy and copy and paste. Oh, and there it is. That looks great. We've got a little bit of clipping here. That's not ideal. A lot of times when instruments clip, you're outside the linear range, so I probably wouldn't save the data from this. But for this short example that I wanted to work through, I think that's enough. I appreciate you all watching. I have links below in the GitHub repository that has the notebook for this, and please hit that like and subscribe button.